Hello guys, I hope you guys are fine. In this video we are going to talk about the implementation of Dijkstra's algorithm. This is the graph that we will be taking as our example. Now this is a weighted directed graph. We are going to look at the adjacency matrix representation of this graph. We are going to code this in C++. My file will be called as dijkstra.cpp and you can check it out on our GitHub link, which is present in the description of this video. Let's start coding it out. So it is hash include iostream using namespace standard. I'm going to use an adjacency matrix representation, which simply means that this has 5 vertices. So I will be using a 5 by 5 graph, all initialized to false. And I'll be constructing a function called addEdge function, to which I will be passing this graph representation G, and then the vertex, which is the source vertex, which is U. In this case I'm dealing with 0, and the destination vertex, which is 1, and I'll also pass the weight on this graph 2. The other edge that goes from vertex number 0 is the vertex with destination vertex 2, and the weight is 4. Let's look at the other one. Now if I take into consideration vertex number 1, there is an edge going from vertex 1 to vertex 2 and the weight is 1. There is another edge that goes from vertex 1 to vertex 3 with the weight of 4. So vertex 1 to vertex 3 with the weight of 4. And there is another one which goes from vertex 1 to vertex 4 with a weight of 5. So vertex 1 to vertex 4 with a weight of 5. Okay, let's look at vertex number 2. There is an edge that goes from 2 to 1. So I will highlight it. There's an edge that goes from 2 to 1 and it carries a weight of 5. Okay, there is no self edge here, so there is no edge from 2 to 2, and there is an edge from 2 to 3 which carries a weight of 2. There is also another edge which goes from 2 to 4 with the weight of 3. Let's look at vertex number 3 now. There is an edge which goes from vertex 3 to vertex 4 with the weight of 1. So vertex 3 to vertex 4 with the weight of 1. There is no other edge which is emanating from vertex 3. There are no edges which go out from vertex 4. So let's complete the definition of the addEdge function. I will receive the graph representation here. Vertex U is my source vertex, vertex V is my destination vertex, and W is the weight on the graph. So I'm writing GU GV is equal to W, thereby saying that from this source to this destination, instead of 1, right, in an unweighted graph I use 1 to denote the presence of an edge. Here I am storing the weight as W. I will also be making use of a function called Dijkstra. I'll pass the graph representation and I will also pass the source vertex. So in this graph, the source vertex is taken to be vertex number 0. Let's code out the Dijkstra function now. I will receive the graph into G. Remember, I have 5 vertices and my source vertex would be called as S. I will keep a boolean visited array which tells me which all vertices we have visited so far. So 5 vertices, all set to false. I will also make use of a distance matrix or an array. Initially, all the values in this distance array are set to the maximum integer value. We can do this by writing dist I equals int max for distance of S, which is the source vertex. I'll set it to 0. I will run a loop from 0 till v minus 1. V is the number of vertices, which are 5. 5 minus 1 gives us 4. So I'll run this loop 4 times. I'll repeat this procedure 4 times. I will keep the source vertex, remember, in Dijkstra's algorithm, We are supposed to find the minimum distance. How would I find the minimum distance? I will be making a function which returns me the vertex which has not been explored so far and has the minimum distance. So in order for this function to work, I will give it the distance array. I will give it the list of all the visited vertices. Let's code it out first. So it will not be void, it will be integer. Find minimum distance. Distance is received in the distance array and visited is received in the visited array. Let me take a variable minimum. I am initializing it the maximum integer value, and I'm taking the index variable to contain the index of the vertex which has not been visited so far and yet carries the minimum distance. I will explore all the vertices. So I is 0, I is less than 5, my vertices range from 0 to 4. If you encounter a vertex which is false, which means it has not been visited, and the distance of this vertex is either less than or equal to the minimum distance that we have encountered so far. So I will update the minimum distance with this distance, which is less, and I will update the index with I. What we need to do next is I need to return the index of this vertex, or this vertex which carries the least distance and has not been visited so far. Let's go back to our Dijkstra's function. In this, I'm going to start another loop here. I'm taking v as the loop control variable. So this essentially is all the vertices which I could find which are adjacent to the source vertex u. V is 0, v is less than 5, v plus plus. Now we are only bothered with vertices which we have not visited so far, and there exists an edge. Remember, GUV is 0 for an unvisited or a vertex which is not reachable from this vertex, and it is a non-zero value for all others because we changed it here in our add edge function. What we are going to do next is I have a unvisited vertex and I have an edge, and the distance to the source vertex is not int max, right? It has been updated, and the distance to this vertex happens to be greater than the distance to the vertex u, the source vertex, and the distance required to reach, which is available in GUV. So what do? I update the distance to this vertex by writing distance of u plus g of uv. The only thing left now is to print out the distance from the source vertex to all other vertices. So I run a loop and I write down cout, which is my source vertex 0, and I will go ahead and I would my dist_i vertex will contain a list of all the distances from the source vertex, so I'll simply update it. Let's compile and run it here. So g++ dijkstra.cpp, got lucky there, no errors, /a.out. So I am getting a couple of int max values. This is something that you shouldn't have happened. So there's something that we are missing here. We did not mark our vertices as listed, which needs to be done here. Let's check our code again. We clear this out. Got lucky again, no. And here it is. So 0, 2, 3, 5, 6. If I go back to our example, the last step 0, 2, 3, 5, 6. These are our updated distances. Thank you guys. I hope you enjoyed this video. Take care. Be safe.